most of you are thinking of what you want to do in the future. Hopefully, well, I'm kind of in the middle right now, and so, well, I'll tell you my professional career. So, so how many of you like math? Okay. Science in general? Okay, that's good. Are you here because you like math, or you're trying to figure out it's worth liking it, or I don't know. So you like math, that's good. I like math very much. Actually, when I was in school, I struggled with very simple things in math because I was very confused by the fact that they were telling me, for example, y minus times plus was minus. It was like a y, like a, so things like you learn, but I question, you know. So eventually, okay, so what the main idea of my talk is, I think that it's very important to do what you like, okay, and also to be flexible. Why is it important to do what you like? Here, in the Bay Area particularly, it's extremely competitive. So if you are trying to compete with people and you don't like what you do, you're screwed because you won't be able to, you don't have a chance. You need to do what you like. Okay, so that's important thing. So along my presentation, I'm going to show you how I figured out what I like and what things I decided to compromise and what things I kept. So I was born in Peru in 1963, so that makes me, what, 55 and 56. My father was a physician. My mother was a college professor of sociology at Vermont. At 72, she earned a PhD in philosophy. Okay, so also my father was a researcher. He made the first kidney transplant in Peru. So talking about science and etymology was a very important thing. Those kind of things was very, very normal. And so, as I said there, my parents awakened my scientific curiosity very, very early on. In 1968, okay, so there was a military coup in Peru, and but we chose to stay. It's like my father had trained in the States, so he had contacts that he moved to the States and worked here. But we thought that it was, I don't know, like our duty. Well, I was too young to think of these things. I was 8 years old, but they decided to stay. So this is a picture of, well, one episode in the Revolution of 1968. That's where that was out. So some people left, a lot of relatives left. But it's kind of like that make you think what happens now in Venezuela. It's kind of like the same thing. Things change. Well, so undergraduate. So I have an undergraduate degree in industrial engineering. That's kind of a compromise between mechanical engineering and business. So what happened is that, at least in Peru, engineering jobs don't pay very well. So basically, what people aspire is to end managing people who do engineering. So that's the way you feel a little bit about with a higher salary. And but I didn't like both. But I'm not getting there yet. So that was what I studied. So I did a couple of internships that pretty much made me think that I didn't want to manage at all. I worked in a small telephone company where they make phones. They basically assemble them by hand. And I had to measure something that is very common in, there's something called, I think, process engineering, where people try to figure out what's the best way to do things. You know? So that was the idea. So you see people assembling things and like, for example, one very basic concept from methods engineering is the only way you can do something faster is by doing several things at the same time. Because you will only have you cannot go faster than you can achieve time, basically. So the only way to make more of the same thing is to do it in parallel. Okay, then also I worked in a construction plant for a construction company, and we were in charge of monitoring resources, like how many trucks are in the garage, and excavators, cranes, and those things. And what I learned from there is that I didn't like managing at all. So I didn't like to supervise, I didn't like that. I like engineering. That was I like science, but being an individual contributor, like let's say sitting on my desk and thinking and being able to do that is very difficult there in Peru. Because like, there are not very many engineering jobs or well-paid engineering jobs. So my first job, actually, despite of all what I said, was along the, kind of like what I was supposed to do, according to, let's say, from following the social pressure. I took a job far from Lima. Peru is very centralized. It's like it has like half of the population of Peru lives in Lima. So pretty much when you meet somebody from Peru, you have 50% chance of knowing that he's from Lima, because that's the way it is. So I'm from Lima. So I took this job like 120 miles away from Lima, and I was in a textile plant. Again, I lasted 3 months. I didn't like it. So then I came back to Lima, and I thought this was a little bit more interesting because here I had the opportunity to be an individual contributor. So at IBM, I started working for IBM del Peru. So this is the building, a nice building. And they trained me to be a systems engineer. So what you do is you go to customers and help them use the product that you sold to them, and also you persuade them to buy more. That's kind of like the idea. So it's kind of like along that. It was helping the marketing department. So it's engineering to support marketing. Okay. So if you have any questions, feel free to interrupt me. And so there, I started feeling like kind of like I was not very intellectually challenged. It was, well, like they to learn the stuff, how to use the equipment, and there's not much more to do. So, and I saw that there were pretty much 3 career paths to either go with management, so eventually you kind of like prove that you are the best of the group and you are the more capable of managing a group, or go into software or into hardware. So I already said I didn't like to manage or to supervise or any of those things. So that was not an option. Software, by some reason at that point, I never liked software. I never liked, I write code today. Okay, that's what I do professionally. But I don't like writing code per se. I like what I do with the code, what I'm trying to solve. But there are people that love writing code. They love, like, let's say, there are people that work that they can tell you what are the new features of Windows, whatever the number is. I use Windows and I don't even know what the new features are. I hate when they change it because I need to learn new things. So that's the way it is for me. But I'm a pretty decent programmer because out of need. And what happens is that when you do something a lot of times, you find out ways, let's say, to use the tricks or the resources that are available to do things better. And if you're lucky and you're in a good company, as the one I am in now, you have people that can tell you a lot of good tricks. So, okay. So then, I decided to come to the States, or I started thinking how I could do something that I was passionate about. And actually, it's very difficult, like, to say, I guess probably you can tell that I was a good student, and I was, let's say, it was not difficult for me to learn things. But it was very difficult to me when I joined IBM to compete with people that were very driven. Because I just, okay, I know this is easy, but I was not driven. And that's actually a very important thing. It's like you need, at least, you need to like what you do. That's very important. Or somehow find something that is within the things that you like. But trying to follow a job because they told you that, I don't know, that has prestige or something like that, I think that it will be difficult because eventually you, okay. So I started thinking of telecommunications because I guess it felt like more engineering, more difficult. You had lots of potential to improve because at that point, like now we take for granted that there is internet and all that stuff. At that point, there was no. I'll get to that. Like when I was in IBM for the first time, I think I remember like we were using some kind of email within the company, and for the first time, some people were using, let's say, phone, let's say voice over the data link between the different IBMs. Okay, that was so, and the voice sounded very strange. You know? Today, you know, like for example, most of the time when you do Skype or many types of communication, you're actually using a data path, and your voice is being digitized. Like this is the other way around. The paradigm has changed already. You know? So it's kind of like, it's like I remember like when I was a kid, like when I was like 17, that's when the first small computers were showing up, like Commodores or like the Apples and those things. And so I have lived through that. You know? A little bit delayed because I was in South America, but it's kind of the same thing. So, also, I realized that since I had some training in engineering, I had a bachelor's in engineering, and I was working with computers, that could help me to get let's say, to a spot where it was good to try to get a master's in telecommunications or something like that. So, but it was not perfect, so I started taking courses in my university, and actually that's also very important. I've been like studying forever. It's like I studied, like I went to school, then I went to got my bachelor's, then I took courses once I was working, then I came to the States, and now you see. So my brother went to the States, and that was a way to he offered that I could live with him. So I applied to pretty much, I think that to every university in Washington D.C. in the metropolitan area, to anything that I could go for visa by metro. That was the idea. And there was another revolution happening in Peru again. There was another, so Alan Garcia, that's eventually became a president in another period, like 15 years later after this picture was taken. So there was uncertainty. So I decided to come to the States. So I started at GW, George Washington University, in fall 1991. So, and actually that's I did very well in my, so since I was trying to get into communications and I was a mechanical engineer, I had to take a lot of prerequisite courses. Like it was, so I think I spent like almost 1 year taking prerequisite courses. Electrical engineering is very strong in math. I think that is the strongest in math. You need to know a lot of math. So I had a strong math, but I didn't know the types of math that you need for electrical engineering. So I impressed a young professor. He's 1 year younger than me, and he was already a professor. He was in the tenure track at George Washington University, and he asked me if I wanted to do work in semiconductor physics. And well, that was kind of like interesting because that was nothing that I had ever thought of doing, but it sounded like very interesting. And the most important thing that offered the means to pay my tuition. So I was able to do my master's and PhD in the same college and never pay for tuition. So that was like a blessing. And so I focused on modeling single devices. And let's say, just to give you an idea, one of the, let's say, I guess Apple phone, an iPhone, may have like 100 million transistors. So my work was focusing on how one of them work. You know? It's something that you describe, and then you figure out how to use them in let's say, how to simulate them as a group. You know? Because you can do very little with a single one. You know? So I also, things that were interesting is I taught some courses and taught spies. That's very important because what I do today is very close to SPICE is actually SPICE is a program for simulating software, for simulating circuits, and it was developed at Berkeley. And it's funny because let's say a lot of the simulation of devices these days is done with SPICE or with programs that derive from SPICE. And one of the people that wrote, once I interviewed for a job, I didn't get the job, but one of the guy that very instrumental in writing SPICE. So once, let's say, now after studying, I don't even know how many years, in the like 8 years, I think, for the master's and PhD, I was, well, need to get a job. And so actually, like postdoc jobs are pretty much the job that PhDs get what they are getting when they're looking for a job. So that's what I did. And so actually, this is just the kind of thing that I was solving, trying to find those little arrows they show the direction of the electric field. So that's the structure, and the idea is to, one of these tiny devices is very big there. You can put like, think that you can put 500 million of them in a Intel chip. One of these devices is how the current distributes along them, and which explains how this device works, is the kind of model that I was doing in my PhD. So at that point, so once I finished with my studies, I was at that point a postdoc student. And it was the middle of the dot-com era. So, this is my wife told me, write this down, like, so pretty much if you had a PhD and a pulse, you got a job. So they moved me to the Bay Area. I don't know, like thinking of moving and paying the truck and moving your car is a lot of money, you know. So I don't know if I had ever thought of spending money to go to a different place just to get a job, but they did it for me. So they offered me a job, and they came with a gigantic truck, and they took all my stuff. They put in the truck so many things that it was never worth moving, that I should just be happy. I would have been happy if they had given me a check, and I would have bought a new car here rather than bringing my old prison. Geo prison, that's the car I had. So I got a job at Sun Microsystems. Actually, that's a very interesting story. Sun Microsystems campus is the one Facebook's campus. So it's a very funny thing because they have the light. I don't even know what, like, I think that's what is in the sign, the light, the thumbs up, you know. So it's funny because a lot of people that come to Silicon Valley, they take pictures of Apple, they go to the light, they take a picture, you know, they like all these things that they live every day anywhere in the world. My cousin lives in Switzerland, she came here and she gave me some friends that they were taking pictures because there, everybody knows Google, everybody knows a lot of things that happen here. Though. But going back to Sun Microsystems. So that's what the name behind the Facebook light. So if you go to the campus, okay, and you go to the sign, and you look behind, you have the Sun logo, and they have left it there because the idea was that if you are complacent, that's the word, like that's what can happen to you, know, that now there's no Sun, there's Facebook that has the usage of forward campus. So, okay, so I had at that point I had a job at Sun Microsystems, which I only had kept for 3 months. No, sorry, 2 years. Yeah, three. I lasted longer. It was like 1.5 years or something like that. So it's funny. I was working again, supporting the marketing department, and the idea was that since I had done a lot of simulation of large programs, I could help. Let's say. So basically, the way it was in those days is that, let's say, there were several like large programs used for different applications. Like for example, like let's say you don't need to crash a car if you want to figure out how it's going to deform. If you hit it against the wall, you can do it using simulation, which is much cheaper. No? So all these companies use large computers like HP, Sun in those days, and PC compatibles. So the idea is that you have to show that those applications could run in your platform better than in the other. No? So that was that. So I tuned and benchmarked EDA and MCAE applications. That's mechanical, CAE is computer engineering. EDA is electronic design automation. So pretty much large applications to design the things that cannot be designed in any otherwise. No? So unfortunately, it was a job very similar to the one at IBM, and I didn't like it. And I was laid off in the first round, which was painful because kind of like this is very depressing to be laid off. But at the same time, I guess it solved a problem for me because at that point I was, let's say, I was single. No, I had very little overhead, no kids. So it was not that difficult to survive without a job. But also, the thing was that, so now I had to look for a job in 2002, and this was a very difficult time because it was just after the burst. So everybody was looking for a job. No? And also, it was only possible to get a job if you were a very good candidate for the position. You know, like if the match happened to be good. You know? So it took me 9 months to get a job. And during that time, I took courses at UC Extension. And eventually I got this job at AWR in El Segundo, California. So I had to fly to LA every week. You know? So crazy thing, before I even got the job or year was over, I decided to get married. So I don't know what we were thinking. So we decided to get married without me having a job. That was a very strange thing. I think I was just trying to play it safe in some way. So I got married and I joined AWR. So AWR at that point was like, I think like 60 people, and now it's like, it has doubled, but also has been acquired by National Instruments. And it's kind of like a small company that has, show you, so it has this. It has a tool that basically allows you, try to be very comfortable here. So basically, this is a simulation tool, but it's so the idea is you can put things. This is like most CAD tools. You put things that represent reality on a, let's say, on a schematic. That's what it's called, this area. And but the thing is that behind each of those little things, like this one, okay, this is a model. There's a set of equations that describe how this is going to behave if there's some kind of stimuli coming from this other. Yeah. So these guys are, let's say, symbols to set up this circuit and simulate it. So basically, the idea is that you construct something and you find out how it's going to behave. You know? So at AWR, I am responsible for implementing the equations that give life to these things, to the many different parts that you can simulate. So actually, the process of building, let's say, electronic components, like for example, like this guy has some Qualcomm chips designed with this tool. That's actually, so I can pretend that somehow my stuff got here. I don't know, but no, it's true that our software was used by Qualcomm to design some of the chips I did in the iPhone. But it's kind of like amazing because these days you can design, and once you design, you test, you send to the manufacturing plant, and they make a chip that works with a high probability the way you simulated. So you can actually predict what your chip is going to do before you manufacture it. So let's go back to this. Okay. So basically, so as I was saying, that's what I do. So I work for AWR, and so AWR has this tool that allows you to place these components, these device models, and I am responsible for, let's say, implementing the equations to make them behave, show a behavior. I guess there are a lot of math involved, and now the interesting thing is that I'm doing a lot of programming because the process of, let's say, so you write equations, the equations, okay, who's here familiar with Mathematica, the software? Oh, it allows you to do derivatives. Now you write an expression, you differentiate it for you. So, well, I code something very similar, no? And now that's becoming, let's say, I'm enjoying coding not because coding, but it's very interesting writing an expression, kind of like that. When you are taught how to differentiate and all the rules, you kind of like, okay, eventually you become good at that, but it becomes very interesting when you can integrate all those, let's say, techniques into a program that's for you. So so now I write and support a compiler that converts all equations into the expressions that I used to code by hand. So yeah. So is there anything else? Yeah. Okay. So that was so basically, actually, this is I'm trying to show it there. Basically, I have here, let's say, different views of the same, let's say, device, which is a differential amplifier, and these are different graphs that show the response to some type of input. And these, so also one thing that was very fortunate is that this company, AWR, what it does is, let's say, is used to design transceivers. Okay, so what happens is that, let's say, we have heard about the wireless revolution. So basically, wireless is a combination of, it's just using old radio with taking advantage of what a computer allows you to do and change frequencies fast. A lot of techniques that allow you to make, let's say, make wireless happen, which is pretty much be connected, constantly connected. So what happened is that since we designed these people apart, what was very interesting is like, so the way I see it is that the dot-com era was based on putting routers and servers all over the place. And eventually, well, I guess, I don't know, I guess that was completed, or the way at the speed at which you could place, let's say, the demand for servers and routers increased. And then what happened is we switched to the wireless revolution, where the new thing that became popular was iPhones. So all the stuff, and now all the stuff that relies on wireless technology requires designing a transceiver. So that's what has kept us doing well for the last 10 years. I've been with this company now like 17 years. I think that some people, like, it's not that common to last very long in a company here in the Bay Area. I think that I also came to terms with, I like engineering, so if I'm happy in a place where I can do engineering, it's good enough for me. Some people in the Bay Area, there's so much competition, and it's so important to keep advancing that some people are just, I feel like, just switching jobs because something is telling them that they need to move further. And I feel like it's just, well, I guess it's my age perhaps, but I'm happy doing what I'm doing, and I think that's something that is important. Okay, so I think that's pretty much it. No. Okay, this is going back to the initial idea. It's what do I like and where did I compromise? So the things that I like, well, I like STEM. I do differential equations, numerical methods, algorithms, device physics. All the stuff happens to me every day. I'm an individual contributor, I don't manage. That's very important to me. But, for example, I solve circuits rather than devices. I trade to solve devices, which is one of those 500,000, or so 500 million. One of those. Now I solve, well, circuits which have like perhaps 100 devices. It's a totally different, it's a different type of equations, but it's equations nevertheless that I could use some of the skills that I had, but also I had to learn to be able to, let's say, repurpose some of the knowledge that I had. I ended in semiconductor devices rather than telecommunications. For me, it's kind of like, it's okay. It's not a big deal. It's both probably I would have been happy doing telecommunications too. And also, as I said, I wanted to do mechanical engineering initially, and I ended doing electrical engineering. I think that I could have done like material science too. There are many things that, as long as they are like in the, I guess, in the STEM area, they're fun for me. So I guess that's all what I have.
So there were multiple times where you talked about doing what you like, and if you don't like what you do, then you're at a disadvantage.
Yeah.
But what is your advice for finding out what you like if you are not sure yet?
Well, I think the internships and that's a good starting point. Also, I think that a lot of times, like which course you like studying the most tells you a very good indicator of what you like. Sometimes also the problem with courses is that if you have the instructor makes a big difference, like how engaging the person is, like or also like there's a lot of stuff that is taught as if that if you have no idea what it can be used for, and feel like it's totally useless. And when somebody can explain where some things are used, makes a huge difference. And like for example, I'm just thinking of something that I do a lot of like in computer science. I guess in undergrad I studied trees. Trees as a structure, like nodes and trees, leaves and stuff. Like was like probably like something like just interesting, and well, I guess I'm solving that type of structure that I use extremely. It can be described with trees very well, and I'm like, well, now I'm thinking, oh, we can use trees for everything, But it's kind of like, I wish somebody had given me like even like a better like motivation when I took the course, or like some kind of example that was better than the one that was given to me at that moment. So I think that internships are important. I find like, for example, I like science, and I find a lot of interesting things online. There are a lot of like, I don't know, there's this guy that had like, I think his last name is Green. He's a guy from Sun University that has a show about like, pretty much like physics. I think it's a very, I don't know, there's a lot of, I think that the internet is also a very good resource. And I think that also like here, I think that there must be like so many clubs and this organization for younger people where you can speak about it. There has to be a lot of stuff where you can find what you like. I guess. Yeah.
What certificates do you recommend taking? For example, what things you probably see at your work and you say, oh, I would have loved to take that certificate, or like get ready on that program or learn that language or something like that?
That's a I actually I kind of like I'm far from courses at this point, so I don't know, or degrees,
I mean, in the matter of, for example, you know how you can get certified in some sort of program like SolidWorks or like, I would say MATLAB, stuff like that.
well, like for example, MATLAB is a very good program. I think that MATLAB it's kind of like a lot of people do a lot of stuff with MATLAB. It's like I was just thinking of I don't know. Well, one thing is fine. It's like everybody. I think that today when you think of programming, you think of object-oriented programming. I don't think that anyone thinks of structured programming, which was the older paradigm. So I come from that paradigm, and so I think that when you learn programming these days, you are learning you are in the right paradigm. It's like I went from not knowing and you need to learn a new one, you know. But I think that C++ is I think that a lot of people, like younger people, I heard about Python, but I don't know exactly what advantages it has. C++ is kind of like, for me, like seems like a very core object-oriented programming program, sorry. I think that for example, that one of the things that I appreciate the most from my undergrad are the math courses. Like math, physics, all those courses are like, and for example, one thing that has, I think that a lot of things I learned in math were kind of like a little bit like perhaps it was you to learn how to do certain things, but you don't get as good feel for them. Over the years, my intuition has grown about like, that's why you do that. Oh, that's no. But
you talked about going through lots of different jobs and kind of switching your career a little bit as you understood what you liked more. Did you ever feel nervous about switching careers or like scared?
Well, I don't know if the funny thing is that I don't think that I was one of those people that manage their career path very well. Like there are people that are very focused and they try to, I need to switch jobs, I need to change this job. I think that it was more like I'm probably having the wrong job because I'm not liking it, or like so. And also it's like it's if you like what you do, you just show up at work and you'll be doing well because you are happy with it. Like yes, that's the thing. Yeah, I don't know what else to tell. Yeah, I guess. Yeah, and also I think that it would have been interesting to be grow up here in this area. There are so many opportunities. It's a crazy place. Like for example, my son, he's our neighbor. His friend has a 3D printer at home, and they just like things like those. Like, and probably you don't need to have a friend with a 3D printer. You probably can get one there. Like there are some shops where they actually, for example, like they have shops where people can go and do prototypes of things. No, like I went to the most I've been to doing that in the Bay Area. I went to a place that I could do like I like woodworking. Okay, and they actually did something with plastic. They let me cut it because you won't destroy the place. But there's a place where you can get plastic cutters and I don't know, like a larger 3D printer. For example, actually, like I have a friend that works in. They say they even have Autodesk. I think students get Autodesk for free. Like I don't know. Yeah. So I actually have a friend that works there, and they have I think they have a internship for people over your age. Like that actually is one of the ferry boats at the ferry terminal in San Francisco. They have a place and they have all these machines. So there's a very good place. Question? Yes, yes. Oh, no. So I hope I entertain you.
We've got one question. Thank you for coming. We've got plenty of food. Take some home. Take some meals. Please sign out. Please do the